So let's solve the problem. The first, we start by forming the characteristic equation given by a minus lambda I, determinant equals to 0. This will be given by determinant of 2 minus lambda minus 1, 1, minus 1, 2 minus lambda minus 1, 1, minus 1, 2 minus lambda equals to 0. So when you work out this determinant along the first row, we'll get 2 minus lambda times 2 minus lambda squared minus 1 plus 1 into minus 2 plus lambda plus 1 plus 1 into 1 minus 2 plus lambda equals to 0. I'm expanding along the first row. So simplifying this, I'll get 2 minus lambda into brackets 4 minus 4 lambda plus lambda squared minus 1 plus lambda minus 1 plus lambda minus 1 equals to 0. Opening brackets will give me 8 minus 8 lambda plus 2 lambda squared minus 2 minus 4 lambda plus 4 lambda squared minus lambda cubed plus lambda plus 2 lambda minus 2 equals to 0. Now collecting like terms, will get minus lambda cubed plus 6 lambda squared minus 9 lambda plus 4 is equals to 0. Now you can divide through by minus 1 to get lambda cubed minus 6 lambda squared plus 9 lambda minus 4 is equals to 0. Now this is factorized into lambda minus 1, lambda minus 1, then lambda minus 4 is equals to 0. So which implies that lambda 1 is equals to 1, lambda 2 is equals to 2, equals to 1. 1 is a repeated root, and then lambda 3 is 4. So once we get the once we have the eigenvalues, then let's go to eigenvectors. So eigenvectors, let's start with lambda equals to 1. So we have AU equals to lambda U, where U is a vector of the form U1, U2, U3. So we'll have the matrix A is 2 minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. You multiply by U1, U2, U3 should give us 1 times U1, U2, U3. Now, with this, we'll have 2U1 minus U2 plus U3 is equals to U1, which implies U1 or U3 is the same as U2 minus U1. Call this one equation 1, and then minus U1 plus 2U2 minus U3 equals to U2, which implies U3 is also the same as U2 minus U1. Call this one equation 2. And U1 minus U2 plus 2U3 is equals to U3. This means U3 will be given by U2 minus U1. So call this one equation 3. So all these three equations are the same. So we say let U1 and U2 to be some fixed real numbers. So let U1 be S and U2 be T, where not both S and T are 0 real numbers. So S and T, S is a real number, also T is a real number, but then we give this extra condition so that we don't allow all of them to be 0. So that implies that U3 will be U2 is T, U1 is S. So then the vector U will be U1, U2, U3, which will be U1 I put S, U2 I put T, U3 I put T minus S. So which is the same as S0 minus S plus 0 T T. Now this simplifies to U equals to 1, 0, negative 1 S plus 0, 1, 1 T. And so when S is 1, T is 0, we have U1 to be the vector 1, 0, negative 1. And then when now I let S to be 0, T to be 1, then U2 will be the vector 0, 1, 1. Now quickly let's get the eigen vector for lambda 3. So lambda 3, which is 4, will have A U3 equals to lambda 3 U3, where U3 is a vector of the form U1, U2, U3. So we'll have the vector, the matrix 2, minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. You multiply this by U1, U2, U3, then 4 times U1, U2, U3, then we'll have 2 U1 minus U2 plus U3 will give us 4 U1, which implies that U3, if I fix this to the left, take this to the right, I'll get 2 U1, because before U1 minus 2 U2 plus U2. So I call this one equation 1. And then negative U1 plus 2 U2 minus U3 is equals to 4 U2. So this implies that if I take U3 to the right hand side, I'll get U3 is equals to, then I take this one to the left hand side, I'll have minus U1 minus 2U2. This is equation 2. And then equation 3 will be U1 minus U2 plus 2U3 equals to 4U3. This means that U1 is the same as, take this to the right hand side, so we'll have U2 and then plus 4U3 minus 2U3 will be plus 2U3. So this is equation 3. Now replace 3 in 1, i.e. I'll have U3 equals to 2, but where there's U1, I put U2 plus 2U3, then plus U2. This will give me U3 equals to 2U2 plus 4U3 plus U2. So that will give me, taking this to the left will be negative 3U3 equals to 2 plus 1 is 3U2. So which means U2 is the same as negative U3. So let us fix U3 to be T. So then this implies that U2 will be negative T and U1 will be given by, now U1 is U2 plus, so U2 which is negative T plus 2U3, so 2T. So U1 will be T. So when I use these values, then my vector U3 will be U1, U2, U3 will be, where there's U1 I put T, where there's U2 I put negative T, where there's U3 I put T. So then I'll get this as factoring out T, 1 minus 1, 1, T. This T is a non-zero real number. So letting T to be 1, then U3 can be written as 1 minus 1, 1. So this is the eigenvector for that given eigenvalue. So that's what you are supposed to do on that particular problem. Thank you.